Hey there, Joel here, and welcome to my channel Math World. Today we're going to solve the part which was remaining of the entire Goa board math paper that we were solving. And if you have not watched the part 1 video, I've put that link in the description box, and also you will see it on the card over here. We will solve question number 5A because question number 1A to 4D is already solved in the part 1 video. So without wasting much time, let's get started and let's roll the intro. Question 5A is a fill in the blank, and select and write the most appropriate option from those given in the brackets, and it is from the chapter circles, and you have to find out basically the tangent over there. If you have drawn the figure when you're solving it, you will get it straight away, because you are told that the diameter is 10, which means the radius is 5, and one of the side is 12. So considering that it is a Pythagorean triplet, you don't even have to solve it. If you know the Pythagorean triplet, that is 5, 12, 13, then 13 is what you have to find out, and it's already there in as the option number or option B. So yeah, that's the hypotenuse of the entire in that problem. Question B is the proof on circles, which I've already told that it's important. You had to study it. It's simple, and if you have done that, then you'll get your 3 marks. If you have written the statement, the reason, everything perfectly, 3 marks are yours. No one can deduct them from you. Question C and question D are nothing but construction of those triangles, and what should I discuss on them? Nothing. If you have written all the values properly, marked everything, all the intersection, the arcs are perfect, and then you will surely get your 3 marks and for the construction of the circles and 3 marks for the triangles. It's simple as that. So next question is question 6A is fill in the blank from the chapter Introduction to Trigonometry, and this question was, I wouldn't say difficult, but a little tricky one. If 1 upon cot 2a is equal to cot a minus 18, where a is an acute angle, then find the value of a. What you have to do over here is 1 upon cot is nothing but 10. So 1 upon cot 2a directly becomes 10 to a. So when you have 10 in cot, I need to change 10 to cot by writing it as 90 minus the angle, which is 90 minus 2a. And when you do that, the entire calculation, you will finally get 108 divided by 3 after adding and subtracting on either side, and which gives you the answer as 36, and that is option number B over there. Question 6B is finding out the length of the line hypotenuse BG, value of cosec B, value of sine G. I will straight away give you the answers. If you don't know how to solve them, I'll put that link in the description box. Go ahead, watch that video to learn how to solve it. Because if you are not the student who have answered this exam and you are preparing to answer, then you need to learn it. So it's there in the description box. Answer for the hypotenuse, that is the length of BG, comes up to be 25. Sine G is 7 upon 25, and cosec B is 25 upon 24. If you have used the K method, then only you will get your 3 marks. And if you have used the formula, that is for sine G opposite upon hypotenuse, then you will get your marks. Otherwise, they'll cut half mark for this careless mistake. For those students who have calculated the expression for numerical values of trigonometric ratios, Question was 4 upon 3 tan square 30 plus sine square 30 minus sine square 60. So if you substitute the angles correctly, that is 1 upon root 3 half and root 3 upon 2, you will get the answer to be minus 1 upon 18, and if you have done it right, then you will get your 3 marks. The next one is identity. Prove that it's a big identity. I don't even want to read that. There's all cubes and this and that and that. On the right hand side is just the value 2. Looks very complicated. Even I felt when I was just looking at it that it might be difficult, but the moment I tried solving, it was damn simple. All you had to do is find out the LCM, take that LCM, multiply in both those fractions, and when you multiply, open those brackets. Once you open those brackets, the first one and the second one, there's so much that you can cancel off, and then that entire big problem becomes a very small one, and finally you are left with 2 times cos raised to 4 theta minus 2 times sine raised to 4 theta. And if I can take that 2 common over there, and that entire expression can be written as cos square theta minus sine square theta, one bracket, and cos square theta plus sine square theta in the second bracket. And in the denominator, you already have cos square theta minus sine square theta. So basically cancel them off, and what will remain with you is cos square theta plus sine square theta, which from the 3 identities, Pythagorean identity, you know that the answer is 1 over here. So that 2 which is outside the bracket multiplied by this 1 will give you answer as 2, which is equal to right hand side. It's very simple. Try it out if you haven't, and if you have any doubts, my email ID is in the description box. Just email it to me. I will be happy to solve or help you out in solving the problem. Attempt each of the following. Find the distance between these 2 points. Use distance formula, straight away calculate. The answer is 4 root 2 units, or the previous step would be root 32 units. So if you have left it over there, then they might cut half mark for it, or else you might get a full mark. 4 root 2 units is the final answer. You can't solve it further than that. The second one is you have to find out the coordinates of point P, but the tricky part over here is the ratio that is given, M1 and M2, is not directly given to you. You are just given M1 and you are given the total length, that is 5 in total. So minusing 5 minus 2 gives you 3. So M2 is 3 over there, and if you solve it with that, your coordinates come up to be 4 comma minus 1, and if you have done that, then you get your all your marks. Okay, next one is question 7a, and it is from the chapter triangles, and the correct answer is 13.5. that is question or option number C. B1 is the entire proof by Pythagoras theorem. Nothing to discuss on that. It's clear cut solving of the entire proof. I've done these proofs. If you have not watched those videos, link in the description box. 7c is a rider that you have to solve, and you are told that prove that DC square minus FC square is equal to FC multiplied by AF. Many steps involved, but again, not a very difficult question, can be solved. And if you have any doubts, you can write an email to me. I'll be happy to solve it for you. Nothing to discuss much on this. Let's go ahead and solve the next question. That is is 7D, which is from the applications of trigonometry. you have to find out the height of the tank, and I've already solved problems based on this. The correct answer over here is 14.6 meters. Okay, nothing to, you have to multiply 20 multiplied by 0.73 is equal to DC, which will give you as 14.6 as the answer, because they have told you that take root 3 as 1.73, so minus 1 will give you 0.73. If you have solved it correctly, then finally the statement is important in the end, that the height of the tank is so and so. So if you have done that, then only you will get your 3 marks. Let's go ahead and solve that last main question, that is question 8a. And over here there's no much solving, it's just the formula of frustum that you need to know, and the only thing is you have studied the formula, keeping that 1/3 outside the bracket. Here they have just multiplied. The correct option is the first one. Okay, and the second one is a rectangular sheet of paper 40 centimeter multiplied by 44 is rolled to form a hollow cylinder of height 40. If pi is 22/7, then the radius of the base of the cylinder is dash. The correct answer is 7, that is option number B. I guess most of the options were option B. I don't know how come, but that's the correct answer. The next one is next one is, in the figure given below, AB is the diameter of a semicircle and AXB is an arc. So if AB is 16, then find the length of arc. Simple question, simple figure. Correct answer is 8 pi centimeter as the length of the arc. I hope you have written the units centimeter over there, because if not, then you will lose a mark, 1 mark. And in the second part, that is find out the area of the semicircle, it is 32 pi centimeter square. Pi was not to be substituted, that's the reason it is there in the final answer. Question C is to find out the area of the shaded region. The figure that is given to you is a trapezium. You have to know the formula to find out area of trapezium, which is a plus b upon 2 multiplied by the height. I know that BC in that figure is height because there's a perpendicular, a 90-degree marked over there. Now the tricky part, you can easily calculate with that formula that I've already told you, area of the trapezium. The next part is to find out the area of the semicircle, or the entire sectors that are there. In 2 sectors you know that the angle is 90, but the others you don't know. So is the question wrong? No, it is not. You need to understand that when it's a 4-sided figure, the sum of the interior angles of that figure will always be 360. So, and since the semis or the sectors that are drawn are with the same radius, that is 3.5 for all those figures, what happens is it practically becomes a circle, because circle will have 360 degrees. So you can directly find out area of trapezium minus area of circle, and when you do that, you will get the area of the shaded region. So the answers for those questions are: area of trapezium is 63 centimeters square and area of circle is 38.5 centimeters square. And when you minus these two numbers, you get the shaded region to be 24.5 centimeters square. And the last question, that is question 8D, is a cylindrical container whose diameter is 12 centimeters. I have already told you, whenever diameters are given, straight away change it to a radius. Is 12 centimeter, height is 15, is full of ice cream. The whole ice cream is to be divided amongst 10 children in equal cones surmounted by a hemispherical top. So if the perpendicular height of the conical portion is twice the diameter, so we don't talk about the diameter, we talk in terms of the radius. So I will say if diameter is 2r, then twice the diameter will be 4r. So taking that, all I have to do is write down the formula of the cylinder equal to 10 times bracket volume of cone plus volume of hemisphere. So I have solved the entire problem together, and once you do that, you get your radius to be 3. There are times when students calculate it separately, like finding the area of the cylinder, then finding, but it takes a lot of time. You can cancel when you do it directly. So the final answer is radius is 3 centimeters. I hope you have scored maximum marks for this entire paper, and hope you liked this video. If you did, then don't forget to hit the like button, share the video with your friends, and subscribe to the channel. Till then, this is Joel saying bye to you. Take care, God bless you, and if you are supposed to answer your next papers, then all the best for them, and if you're preparing, still good luck, do well.